7091. During a Pinnacle approach to a rooftop heliport under conditions of turbulence and high wind, the pilot should make a shallow approach, maintaining a constant line of descent with cyclic applications. B. Normal approach, maintaining a slower than normal rate of descent with cyclic applications. C. Steeper than normal approach, maintaining the desired angle of descent with collective applications. The correct answer is C. A Pinnacle approach refers to a specific type of helicopter approach used when landing on a rooftop heliport, typically located on a high-rise building. This type of approach requires careful control and adjustment due to the challenges posed by turbulence and high wind conditions. In such conditions, it is crucial for the pilot to maintain control over the descent and ensure a safe landing, maintaining the desired angle of descent with collective applications. By choosing a steeper approach angle, the pilot can better counteract the effects of turbulence and high winds. A steeper descent allows the pilot to maintain a higher degree of control over the helicopter, as it provides a more direct and controlled path to the landing spot. This can help minimize the effects of crosswinds and turbulence that may cause the helicopter to be pushed off course or experience instability. In addition to the steeper approach, the pilot should also utilize collective applications. Collective control refers to the movement of the collective lever, which controls the pitch of the main rotor blades collectively. Adjusting the collective pitch allows the pilot to control the overall lift generated by the rotor system. In turbulent and high wind conditions, the pilot may need to make collective adjustments to maintain the desired rate of descent and counteract the effects of gusts or wind changes. By using collective applications, the pilot can fine-tune the lift and descent rate, ensuring a smooth and controlled approach to the rooftop heliport. 7084. Normal rotor RPM should be maintained during a running landing primarily to ensure A. Sufficient forward speed is available. B. Adequate directional control until the helicopter stops. C. Sufficient lift is available in case of an emergency. The correct answer is B. During a running landing, the helicopter touches down while maintaining forward speed and continues to move along the ground until it comes to a complete stop. Maintaining normal rotor RPM, rotations per minute, is crucial for maintaining adequate directional control during this maneuver. The rotor system of a helicopter provides lift and also generates thrust that helps in controlling the helicopter's direction. The rotor RPM directly affects the amount of lift and thrust produced by the rotor blades. By maintaining normal rotor RPM during a running landing, the pilot ensures that there is sufficient rotational energy in the rotor system to maintain control over the helicopter's direction until it comes to a stop. A consistent rotor RPM helps maintain a stable airflow over the rotor blades, which in turn provides the necessary lift and thrust for directional control. If the rotor RPM is too low during a running landing, the airflow over the rotor blades may become insufficient to maintain lift and thrust, leading to a loss of directional control. This can result in the helicopter veering off course or becoming difficult to maneuver. Additionally, maintaining normal rotor RPM also allows for quick adjustments in case of any unexpected changes or corrections needed during the running landing. The pilot can make fine adjustments to the collective pitch or cyclic inputs to maintain the desired direction and prevent any deviations or instability. 6694. During the transition from prerotation to flight, all rotor blades change pitch? A. Simultaneously to the same angle of incidence. B. Simultaneously but to different angles of incidence. C. To the same degree at the same point in the cycle of rotation. The correct answer is B. During the transition from prerotation to flight in a helicopter, the rotor blades undergo a pitch change to generate lift and provide the necessary thrust for takeoff. All rotor blades change pitch simultaneously but to different angles of incidence. The angles of incidence refer to the angle at which the rotor blades meet the oncoming airflow. Each rotor blade adjusts its angle of incidence individually to achieve the desired lift and thrust distribution across the rotor disc. While the blades change pitch simultaneously, they do so to different angles of incidence to create a balanced and efficient lift force. The angle of incidence of each blade may vary based on factors such as its position in the rotor disc and the desired distribution of lift. The individual pitch changes allow for a more even distribution of lift across the rotor disc, which helps maintain stability and prevent any imbalances during the transition from prerotation to flight. It also allows for adjustments to compensate for any asymmetric loading or external factors that may affect the rotor system. By changing pitch to different angles of incidence, the rotor blades collectively generate lift and thrust that enables the helicopter to transition from a hover or prerotation state to actual flight. 6835-1, which are true concerning gyroplane operations. A. Rotor RPM will decrease during a vertical descent regardless of weight or density altitude. B. Minimum level flight speed is established when all available power is used to maintain constant altitude and airspeed. C. A gyroplane can take off from any area in which it can safely land. The correct answer is B. In gyroplane operations, the minimum level flight speed is indeed established when all available power is used to maintain a constant altitude and airspeed. This minimum level flight speed is often referred to as the best glide speed, or minimum power required speed. Gyroplanes, also known as autogyros, are aircraft that have a free-spinning rotor system like a helicopter but rely on forward motion to generate lift. The rotor is not powered directly by an engine, but is instead auto-rotated by the relative wind. This means that the rotor spins due to the airflow passing through it as the gyroplane moves forward. To maintain level flight, a gyroplane needs to generate sufficient lift from the auto-rotating rotor. The minimum level flight speed is the speed at which the rotor generates enough lift to counteract the aircraft's weight and maintain a constant altitude. At speeds below the minimum level flight speed, the rotor may not generate enough lift, and the gyroplane will begin to descend. This is because the airflow passing through the rotor is not sufficient to provide the required lift. Therefore, to maintain level flight, the gyroplane must be flown at or above this minimum level flight speed. Using all available power means that the engine is providing the maximum thrust available to maintain the desired airspeed and altitude. By utilizing maximum power, the gyroplane ensures that it is operating at the most efficient speed for level flight, where the lift generated by the rotor is balanced with the aircraft's weight and drag. 7092, which is true concerning taxi procedures in a gyroplane. A. In ideal conditions, taxi speed should be limited to no faster than a brisk walk. B. Cyclic stick should be positioned slightly aft of neutral when taxiing. C. Rotor blades should not be turning when taxiing over a rough surface. The correct answer is A. When it comes to taxi procedures in a gyroplane, option A correctly states that in ideal conditions, the taxi speed should be limited to no faster than a brisk walk. Gyroplanes are aircraft that rely on forward motion and auto-rotation of the rotor system to generate lift. They have a relatively high center of gravity compared to other aircraft, which makes them more susceptible to tipping or rolling over if operated at excessive speeds during taxiing. To ensure safe ground operations, it is generally recommended to keep the taxi speed of a gyroplane no faster than a brisk walk. This ensures that the pilot maintains better control and stability of the aircraft during taxiing. By limiting the taxi speed to a pace no faster than a brisk walk, the pilot has more time to react to any potential obstacles or changes in ground conditions. It also allows for better maneuverability and precise control during turns or directional changes. Moreover, taxiing at a slower speed reduces the risk of dynamic rollover, which can occur if the gyroplane exceeds its critical tipping angle during quick turns or abrupt maneuvers. By maintaining a speed no faster than a brisk walk, the pilot minimizes the likelihood of losing control and maintains a safer taxi environment. However, it is important to note that the specific recommended taxi speed may vary depending on the manufacturer's guidelines, aircraft model, and operating conditions. Pilots should always refer to the aircraft's operating manual and follow the recommended procedures for safe ground operations.